Okay, so let's get started. My name is Troy Snyder. I'm a student at U of A, and I'm presenting my GIST Master's capstone project. It's a geographic analysis of heat-related deaths in Maricopa County, Arizona. So, so first of all, I chose this topic because it is a very pressing issue right now that the desert Southwest, in particular in the U.S., has been experiencing. They've been experiencing extreme temperatures, extreme weather, and a lot of lives have already been lost in that area, and also other parts of the country, even worldwide. And measures need to be taken to address this issue and to help save lives. So the purposes of my study are threefold. The first is to identify key factors that lead to heat-related deaths in the study area. The second purpose is to determine if there's a spatial relationship between these factors. And then the third is to identify areas where help is needed, basically areas that need improvement to help improve the lives of the residents. So this is my study area, Maricopa County. It's located in south central Arizona. You can see it right here, and then blown up right here on the right. It's a rather large county by United States standards. It's about the size of the state of Massachusetts, just to give you some reference. And just looking at this base map here, you can see it is home to the city of Phoenix, as well as the Phoenix suburbs. To the northeast, there's Mountain Range, and then to the west and southwest is the Sonoran Desert. Basically, it's pretty desolate down in this region. So those are some things to keep in mind as we go through this study. Just to give you a quick rundown, I'm going to go through my data and methods, followed by my analysis steps, my results, and then conclusions and next steps. So my first data source was from the Maricopa County Flood Control District. They have 30 weather stations located throughout the county, and I gathered temperature data from those sources from this source. The next one is the Arizona Land Resource Information System, or ALRIS. They basically just published this shapefile, which is the boundary for the county, which I used for clipping and different aspects of my analysis. I also used a ortho image from the USDA National Agricultural Imagery Program, or NAIP for short. And basically, it's just satellite imagery of the county. And this, in its native form, it shows vegetation in red. So they use this kind of imagery a lot for vegetation, but I actually used it for a different purpose, which I'll explain in a minute. And then my next source was the Arizona Department of Health Services. They had a shapefile of polygons of these primary care areas, which are basically a way to divide up the state into healthcare regions. So I used those for clipping and for mapping different things. So first I collected weather station data and analyzed it using an IDW, or inverse distance weighted method of interpolation. I'll show you that here in a minute. Next, from the USDA, I got that NAIP ortho image that I showed you, and I clipped the imagery to the county boundaries and used a supervised classification using support vector machines, or an SVM method. And this basically, I just used this to show areas that would be prone to developing urban heat islands, and I'll explain what those are as well. And then from the Arizona Department of Health Services, I collected historic heat-related death data and mapped that using a choropleth map. So this is the first map that I produced. It's an inverse, it uses the IDW interpolation. Basically, it takes the number of days from May to October 2022 that were over 100 degrees Fahrenheit. And so I mapped them based on colors. So the lighter colors are lower temperatures, and darker to red colors are higher temperatures or higher number of days. So you can see that the central part of the county and also western portion had the most days over 100 degrees Fahrenheit during this time period. You also can notice that this doesn't cover the whole county area. It just covers the area that was covered by the weather station. So basically the extent of the weather stations within the county, which was kind of a limitation of this. My next map is also an IDW interpolation showing the number of days from May to October 2022 that reached over 110 degrees Fahrenheit. So the minimum was 1, maximum was 26. I'm sure this year they've probably beaten this because it's been such a hot year for them. But you can see some trends in the western portion of the county and also central part that experienced the most days over 110. Phoenix suburbs such as Glendale and Peoria, as well as downtown areas too. Okay, and then this is my classification that I did, the supervised classification using support vector machines of that ortho imagery. And I basically, how this works is there's a tool in ArcGIS Pro that you can use called the classification wizard, and you can train it to identify areas based on development or based on what they look like. So my 4 classes were water, which is shown in blue, developed land, which is shown in gray to kind of represent concrete, shrubland, which is represented by the brown, and then planted or cultivated land, which is represented by this bright green color. So you can kind of get an idea of the makeup of the county. Next, I used historic death data, heat-related death data from the Arizona Department of Health Services, and I mapped it using a choropleth, which is basically just using colors to represent the data. And so the lighter colors are the fewer number of deaths, and going to the darker colors, which maximum number of deaths was 47 for these 2 primary care areas. The challenge with this data was that it was pretty limited. There were a bunch of these primary care areas that did not have any heat-related death data for the time period, but I just worked with what I could get. So you can kind of notice a trend that the central portion of the county experienced a lot more heat-related deaths than many of the other areas. So just to revisit my threefold purpose, again, it was to identify key factors that increase the risks of heat-related death, to determine if there's a spatial relationship between these factors, and then to identify areas where solutions could be implemented. And these are my resulting maps. So this is a representation of that first map that I showed you, but with the highest risk for temperatures over 100 degrees, or number of days over 100 degrees Fahrenheit, based on these primary care areas. So I basically just highlighted the primary care areas that experienced the most days over 100 degrees Fahrenheit in 2022. Same with this one. These are the primary care areas highlighted in blue that experienced the most days over 110 degrees Fahrenheit in 2022. And then I took my classification of the ortho imagery and did a custom symbology, basically just to show, to highlight the areas that are developed or not developed. So basically what I did was I applied this color ramp to those areas, with the lightest areas having the least amount of development or the least likelihood to develop urban heat island effect, and then the darker areas in darker red to show a higher likelihood of developing urban heat islands. And I want to go over that really briefly. What is an urban heat island? Essentially, urban heat islands are formed in areas that have a large built environment. So they're pretty much, urban areas with a lot of pavement, a lot of impervious surfaces. These surfaces by nature and also based on their color, like for example, blacktop pavement, that sort of thing, they'll absorb a lot of the incoming solar radiation, and then it increases the heat dramatically in the area, both during the daytime and at night, which can make conditions very dangerous for residents. Whereas, you can see these rural areas or even suburban areas with green spaces, even parks, have less of a likelihood of an urban heat island. So that's why I chose to symbolize this as such, basically showing that planted or cultivated areas, because there is less absorption of solar radiation, more reflection, have a less likelihood of having urban heat islands developing. But the developed and urban areas, basically the areas identified as having the most pavement and buildings, have a much higher likelihood, and therefore the temperature could be significantly higher and even more dangerous in these areas. So then I just identified the primary care areas, or PCAs, that had the highest likelihood of experiencing the urban heat island effect, and just highlighted them here in yellow. Basically, I just looked through the primary care areas, I overlaid them on top of this map, and identified the ones that had the most development within their boundaries. My final map shows the primary care areas with the greatest total risks as far as contributors to heat-related deaths. And those are Alhambra Village, Central City Village, and Glendale Central. These are all located within the central portion of the county in Phoenix area. And these three areas had the most, or the largest number of days that reached over 100 degrees Fahrenheit in 2022, the largest number of days that reached over 110 degrees Fahrenheit, and also the highest urban heat island vulnerability and the highest number of historic heat-related deaths. So basically, in my study, all fingers pointed to these areas as needing improvements to help protect lives. So in conclusion, there needs to be some action taken to address these heat-related issues, especially in those three primary care areas that I found to be in need of most help. Some further studies that you could do after this could be a network analysis. So you could take into consideration the hospitals and emergency medical services that are available in areas throughout the county. And basically using GIS, you could do a network analysis showing how long it takes to get to medical care, because that is also a crucial factor that I didn't have time to cover. Another thing you could do is a more long-term climate study. So identifying or gathering data from decades of data for temperatures and different factors to humidity, different factors to consider that would contribute to heat-related deaths. And then urban heat island studies themselves would also be beneficial. So just studying more, what goes into causing these effects, and how do they relate to health impacts and different things like that, just diving deeper. Some potential solutions that I identified during my research for this project were, first of all, cooling centers, which Maricopa County has quite a few. They actually have a website. Their county website has an interactive map where you can find cooling centers. Basically, these are public places to go that are air conditioned, that have water, different things available to help you find relief from the heat, which these have been very effective in helping people stay alive and stay well. But I'm sure that there's probably a need for more of these. Most of these cooling centers are public libraries or public buildings, and there could be a need for more of these cooling centers, even from private businesses, etc. Another potential solution that we could look into is the implication or the application of green roofs and living walls. Basically, this is infrastructure that's attached to buildings or part of buildings in urban areas that incorporates plants. And pretty much what this does is it helps to cool the interior and exterior of the buildings, and helps to decrease the temperature on the outside because of the evapotranspiration of the plants, and also the plants absorbing that incoming solar radiation. And also it helps improve air quality because the plants are, filtering out the bad stuff. And I'd just like to finish by acknowledging my sweet wife, Casey, my family members, coworkers, and friends who helped me get this far. Also, thanks to you, Dr. Mason, and others of the GIST faculty and staff for all your support. And now we can open it up for questions.
Thank you,